In this video, we're looking at alkynes. Now, alkynes are hydrocarbons that contain a triple bond between two carbon atoms in our chain. So you will see that triple bond present as drawn here. The other way we can tell is by looking at the formula or the name. So if the chemical formula follows this pattern, CnH2n-2, so the number of hydrogens should be whatever the number of carbons are times 2 and then take away 2. That general formula will give us an alkyne. And if you look at the name of the compound, you will also see yne, Y-N-E, at the end when we're looking at it. So an example we might have could be C4, and then to follow that pattern, 2 times 4 would be 8. We take away 2, so we're going to get C4H6. That's an example where we could have an alkyne. So if we look at this, we could see potentially our triple bond in our chain of carbons. It could be at the carbon 1 location. We don't have a name for it. So if we start by drawing, we could put it here. Remember that carbon needs 4 bonds around it. So with the triple bond, this first carbon only needs 1 hydrogen attached to it. The second carbon already has 4 bonds around it, so it doesn't get any hydrogens attached. And then our second last will get 2 in order to fill the bonding capacity of 4. And then our last carbon should end up with 3 hydrogens around it. So when we're done that structure, you'll notice that we've got a scenario here where we've got 4 carbons. There's a triple bond located in there, and we follow that C4H6 chemical structure. Now, the name of this one, if we want the name of this, because the triple bond is at carbon 1, we would actually have a 1 in front of the name, and this is 1-butyne. Okay, where but is standing for the 4 carbons, and we'll get into that when we learn more about naming. But that's one way that structure could be drawn. The other way that structure could be drawn is with the triple bond located in the center, right? So at carbon 2, if our triple bond starts there, we could get this particular hydrocarbon. And again, looking at hydrogens, we're going to need our 3 hydrogens on the first carbon here. We don't need any hydrogens on the second carbon because it already has 4 bonds. Same with the third carbon's already got 4 bonds. So the last carbon in our chain is going to get the other 3 hydrogens. And there's our formula for C4H6, drawn differently, right? So these two, if you're keeping track of some terminology, these would be considered isomers. They have the same chemical formula, but their structure is different. And so this one, because the triple bond is starting at carbon 2, would be called 2-butyne. So alkynes are really neat with their triple bond. It's going to change their properties, right? So that functional group being present in that structure for your hydrocarbon is going to give us an alkyne. And as these structures get bigger and bigger with more carbons and more hydrogens, you're going to start to see even more isomers possible that could be drawn. Okay, so remember, alkynes, triple bond in your structure in that carbon chain, and they should follow that CnH2n-2 general formula. And you should see by looking at a name, YNE at the end of it. That's how we can help identify that that is an alkyne.